Hey guys, Mr. Light here, going to work with you on today's final page of work. It is uh, April 28th, in case you're watching this on a different day. This video will go over the page 7-13 class activity. It's all about converting units of mass. So we've done a couple pages where we converted units of volume. Here we're doing units of mass. And mass, you probably are thinking about it as it relates to weight. It's a little bit different, but for today's purposes, let's just think of them as the same, okay? So the most common units of mass are grams and kilograms. First thing we do is fill in these missing values here. 1 kilogram equals 1,000 grams. We know that because the K, the K stands for kilo, and kilo is a prefix that means 1,000. And then the other unit rate that's equivalent here is 1 gram is 1/1000th kilogram. So we just did the inverse of that. We just flip-flopped it. And the unit rates here are below, just like we wrote 1/1000th. The way we read this is, on this one I'm pointing to with my cursor, 1/1000th of a kilogram per gram. And then similarly here, another equivalency, 1,000 grams per kilogram. Okay, so both of these two things mean the same to us, and both these things will be very useful to you as a math thinker and as you continue your education, as you get into your science courses, and your teacher will say measure out 2 grams of salt and 14 kilograms of water and mix them together or something like that. I don't know, I just made that up. That doesn't really sound very reasonable, but you will need to be able to convert grams and kilograms pretty fluidly, and you'll find that these are pretty straightforward. So number 15 and 16 here, we're converting, on the first set of problems, we're converting grams to kilograms, and the second problem, kilograms to grams. And so let me take you to my paper where I do a little showing of my work. So problem 15, 3,575 grams equals how many kilograms? Well, the way we find this is we multiply our measurement by our unit rate. We want to select the unit rate with kilograms on top because kilograms are our goal. And so we select 1/1000th of a kilogram per gram. As I multiply, my two units, grams, cancel each other out because grams is on top and grams is on bottom. So grams divided by grams is 1, and we don't need to write 1 all the time. So 3,575 times 1 over 1,000 is 3,575 over 1,000. And finally, we write this as I wrote it as a decimal, 3.575 kilograms is what we're left with for our final answer for number 15. So 3,575 grams is equal to 3.575 kilograms. Okay. Problem 16, we're taking 3,575 kilograms and trying to figure out how many grams it is. So we do something very similar. We take our measurement and we multiply it by the unit rate. But in this case, we want to select the unit rate with grams on top, which is 1,000 grams per kilogram. As we multiply, we cancel out kilograms, and we're left with 3,575 times 1,000 grams, which gives us 3,575,000 grams. And that is our answer. So 3,575 grams is equal to 3,575 kilograms. Okay. Number 17 on the page, it tells us about the mass of a nickel, and it tells us that there's this bag of nickels that weighs 2 kilograms, and how many nickels are in the bag. Let's explain. So here, let me work you through the problem here. So I just kind of listed what we were given in the problem. The first step is to convert to common measurement. I'm going to choose grams here. So I'm going to convert. I don't need to do anything with the 1 nickel's mass right now. All I need to convert to grams is my 2 kilograms, the weight of my bag. And to do that, I multiply by my unit rate. So I multiply my measurement by my unit rate. Measurement is 2 kilograms times 1,000 grams over kilograms, which I get to equal 2,000 grams. And that's the weight of my bag there. Okay. And then the only reason you see this big error is I had arrow is because I had a couple of errors, and I thought I didn't have enough space down here. So if you'll follow my arrow, I take that weight of my bag down here, and now I just multiply it times another unit rate. In this case, it's the unit rate of nickel per gram. So it's 1/5 of a nickel per 1 gram. And so I just multiply 2,000 times this unit rate, and grams cancel out, and I'm left with 2,000 times 1/5, which is 400. It would be 2,000 over 5, which would simplify to 400 nickels. So that's what I'm left with, and I'm going to take you back to my paper to just show you my explanation. So it's 400 nickels in the bag, and the explanation is that I converted all measurements to grams, and I divided the weight of the bag by the weight of 1 nickel. So how many of these little guys fits in this big guy? That's basically what division is. Okay. Pardon. The next couple of problems here, we're doing the same process, but instead of using the metric system, which is nice and simple, we're using our much more complicated imperial system, as it's called, and this is pounds and ounces. And so we're told, there are 16 ounces in a pound. So let's write a couple of unit rates to to square away our thinking. First thing is simple. We write 16 ounces per pound, just like this. The other way we write this as 1/16 of a pound per ounce. Okay, and then 19 and 20, we're just converting pounds to ounces and then ounces to pounds. Let me show you my work on my paper. So 19 up top here, 420 pounds equals some number of ounces. Here we just multiply the measurement by the unit rate. We want to select the unit rate with ounces on top because that's our goal, is to find ounces. And so we multiply 420 pounds times 16 ounces per pound. Pounds cancel out, that's why I slash those. And now I'm left with 420 times 16 ounces. I pump that into my calculator. I got 6,720 ounces. So 420 pounds equals 6,720 ounces. Okay. Number 20 is very similar. We're just going from ounces to pounds, so we're going in the other direction. We're given a measurement of 420 ounces. We're going to multiply that amount by our unit rate, and we're going to find how many pounds that is. The way we do that is we select this unit rate with pounds on top, so it's 1/16 of a pound per ounce times 420 ounces. As we multiply, our ounces cancel one another out, and we're left with the measurement of pounds only, which is good. And now we multiply 420 times 1/16, or 1/16, which we start out the next step, we get 420 over 16, and let's simplify that to 26 and 4/16. Let's simplify it one more time to 26 and 1/4. 4/16 is the same thing as 1/4. Final answer, 420 ounces equals 26 and 1/4 pound. Number 21, we were given measurements of Puppy's weight, and we were asked to compare them. However, the problem that we run into is that Daisy's measurement is 7.5 pounds. Okay, makes sense. Bandit's measurement, though, is 108 ounces, so they have different units, and so we need to convert to a common unit or common measurement. I'm going to convert them to ounces. That was my choice. You could convert them to pounds as well. I just chose ounces. I'm not exactly sure why I chose that, but that's what I did. So the only puppy's weight I need to convert then is Daisy's. She's in pounds. I'm going to convert her to ounces. So 7.5 pounds multiplied by my unit rate, 16 ounces per pound. I cancel out pounds here. I multiply by, so I cancel out pounds and I'm left with 7.5 times 16 ounces. 7.5 I need to convert to an improper fraction. So I do that and I get 15 halves times 16 over 1. And as I multiply top times top, I get 240. As I multiply bottom times bottom, I get 2. 240 divided by 2 is 120 ounces. And so Daisy weighs 120 ounces. Bandit weighs 108. So, of course, Bandit weighs more. Okay? Pretty straightforward there. We're just converting unit rates here for mass on this paper today. Okay? That is all the time we're going to have for this video. Please remember to ask me questions through chat, through text, through phone calls, email, smoke signals, whatever works for you. I'll do my best. I'm available to help. Please keep sharpening your skills and keep your practices up. And I will be seeing you guys later. Thanks for watching.